Hello, welcome to NPTEL live session. Myself Dr. Jayanta from Department of Metallurgical and Materials Engineering. Hello. And I am teaching you the course of Advanced Materials and Processes. So far there are couple of week lectures you must have listened, and there are definitely some questions in your mind, and you have already uploaded your questions in the portal, NPTEL portal, which I and the TAs responded immediately. For today's live session, since we have already covered almost 9 weeks of lectures, which include introduction to metastable and functional alloys, bulk metallic glasses, 2 different weeks, 1 week dedicated for the fundamental aspects of bulk metallic glasses, and the second week was on functional properties and mechanical properties. The fourth week we have discussed about the shape memory alloys, pseudo elasticity, along with we have recapitulated all the necessary fundamental aspect that one need to understand phase transformation, specifically on the diffusionless phase transformation as well as martensitic transformation. Since martensitic transformation is very much well linked to show you the shape memory effect and pseudo elasticity, as well as on the next week, means week 5, we have detailed discussed about the case studies on these shape memory alloys. Week 7 and week 6, we had discussed about high temperature material. The introduction was given on week 6, and week 7 we specifically discussed on the super alloys, their processing, their phase formation, microstructures in nickel based superalloy, cobalt based superalloy, nickel iron based superalloy, and very important aspect that why we always choose FCC matrix as a matrix in a superalloys. And then week 8 we had discussed about the nanomaterial part 1, week 9 nanomaterial part 2, and within next couple of days I hope week 10, week 11 and 12 we will complete to discuss about soft and hard magnetic materials, non-equilibrium processes, mostly the advanced processing technique or the alloys or the materials that we have discussed in these different weeks, that we focused mostly on the processing technique, because until we process the material we cannot realize a product. And the last week we will discuss on the function alloys. So, if I look at the questions that appeared so far, then majority of them from the glassy alloys, and some of you have already asked about, since in a high entropy alloy one can think about let us say higher number of elements, minimum 5, even though that will be discussed in week 12, the last week, as the advanced functional alloys, but in metallic glasses there also we have multiple element, but not like a high entropy alloys, even though these days there are a couple of reports on high entropy bulk metallic glass, means people able to synthesize glasses on a equiatomic composition. Okay. So, here equiatomic means if we think about 5 elements, principal element present in an alloy, then the concentration of individual element is 20%, right, 100 divided by 5. So, it is 20%, and there are couple of reports on that. However, if we think about specifically on the bulk metallic glasses or glass forming alloys, there we have discussed about the critical cooling rate. Yes, even though the diffusion is sluggish in both the cases, in high entropy alloy diffusion is slow, in the in case of metallic glasses which are somewhat like medium or sometimes medium entropy alloys. So, there also the situation is very similar. And now, if I come to today's discussion, where we have only received 2 questions and both the questions are quite interesting. The one of the questions came from IIT Roorkee student Abhishek Somani. Thank you very much for your question. And so, you are basically a undergrad student at IIT Roorkee, and you had already developed some interest because of our this NPTEL course, and I am very happy that you have shown your interest to take this course and listening to the course carefully. And so far you have also asked several questions. I hope you are satisfied with all the answers I have given. And today's question that you have you want to know the prospect of the entrepreneurship in material science, advanced materials. Yes, there is a huge prospect first of all, because these material what we have discussed, they are almost used, a large part of these materials are every day used, and so you can always go for it, and the research we need, that is why the materials are developed. So, we have to conduct research, otherwise how materials will be developed. And so, if you really wish to pursue higher and higher studies and try to develop your own understanding, then you are always welcome to join our IIT and join our group, that is always welcome. And the specific answer that I have prepared for you, that thank you very much for your keen interest. It is definitely great to hear, and if you want to make a post graduation in material science, it is also a very good idea, and I always wish a good luck for you for your future endeavor. And the prospect for entrepreneurship is like that, that in our society, in daily life, sports, medicine, car industry, fashion, electronic components, the materials play the more prominent role. Yes, and materials are being developed with a very customized and specific application. In both way, it is true that we first find out a material and its functional properties, and then we go for its application. And if we have a demand from the market, then again researchers go back and try to develop and satisfy the goal of a specific application. So, both way it is true. And some of these advanced materials or smart materials that I have already discussed, like shape memory alloys, nickel titanium, nickel rich side, and definitely nickel based super alloys, some gadolinium based magnetocaloric alloys for future generation refrigerant material, thermoelectric materials, and one can never, I mean engineers are never satisfied with the property of the material, right. So, we always demand higher and higher, right. So, like more lighter cars, it may consume less fuel, but it should also absorb shock. So, this is a nice example of developing, let us say something like a magnesium based alloy cars. So, instead of steel. So, this kind of demand is always available in the market, and we have to go for it or make the material available for people's use. So, we have simultaneously and technically, and this should be a possible, as well as the route that we should choose for processing these advanced material, that should be feasible in terms of expenditure, right. I can always make some exotic material with a very expensive cost, but as an engineer we must look for alternative way, alternative path for both the property should not degrade as well as material can be synthesized in a cheaper price, and that is one of the very important aspect. Also, we need to think about the recyclability, right. We can keep on making materials and using the resources of our beautiful world, but all material whatever we dig out from the mines and we exploit them, it should ultimately go back to the nature. That is one of the very important aspect of the material scientist. So, like we can always produce many plastics, but that should be degradable, right. And so, the nature should or the material should go back to the nature. Or if there is a metals and alloys are very easy to recycle. You remelt it, you cast the product. If a product has a failure, you take the product, failured product as a scrap material, you melt the alloy and mix it, and that you can always do. But other kind of composite or some other structures, the material should be recyclable. That is also another and if you want to be an entrepreneur and want to establish yourself in this materials field, then you should keep it in mind all these aspects, and these are the proper or you should give proper priority to this aspect to become a good entrepreneur. The research is necessary because otherwise your product will be obsolete. You cannot survive in a market. Any product, if you look at in the market, you have to survive with your product, you have to do research. You have to always make better and better product compared to others. Not only that, it should be more smart, readily available to the customers, and those aspects you have to keep it in mind. So, the advanced material technology processes should be continuously developed with extensive research and analysis. And you may recall on the very first lecture, we have shown you the 4 or 5 major aspect, where we talked about, let us say, the aim of us to make materials with let us say for making or considering human welfare, cleaner energy, right. So, even if you want to make materials, you need power. So, utilize the power where we have more cleaner energy, and keeping in mind that we keep our environment more secure, safety, and the society should be secure, and so that we can make our workforce together. And these are one of the very important aspect, and as I said, these are the idea of 21st century, a strategic development of materials, or we call it as materials genome initiative. And therefore, one has to keep it in mind all these aspects. Now, along this concept, the understanding and relationship between microstructure and properties of materials is also very much important, which require research skills starting from the chemical, mechanical, different functional properties, and one should integrate actually. So, it is not only the materials, but you have to think about mathematics, chemistry, physics, everything together, then only we can make a good product. And considering electrical engineering, civil, so all different engineering fields should come together, because if you recall, different engineering stream has been made to train engineers in a specific field, but if I ask you to develop a product, then all different engineering fields will vanish. So, then everything comes under the same umbrella. So, development of a product is more important, and for that a material scientist has to work with a electrical engineer or civil engineer or mechanical engineer all together. So, this is the workforce we should make together to make a better product or more advanced product. So, one has to deepen his knowledge from the structure of the materials, from a electronic structure to a large scale macroscopic structure, and we have to master ourselves in the manufacturing process. So, advanced manufacturing processes, so that we can evaluate materials properties and develop new product. So, we also need the skill of the persons who work in the ground level. So, those things one has to keep it in mind. Now, that is the second question for today was this, that sir, what is the format of the final exam and how many marks for the final exam? So, your answer is that you must got these questions in every week. This is a weekly assignment that I provide to through the portal to the students, and the format is very similar like the weekly assignment, and that you will get in the final question paper. And we have designed this time like 1 mark question, 2 marks questions and 3 marks questions. And so, both the theoretical questions as well as mathematical questions, means some solution will be there, and the total marks for the final exam will be 100, and already NPTEL website displayed that how is the ratio of the assignment and the final questions and so on. So, those things are already available in the website, and if you still have more questions, you can always ask through the NPTEL portal. I am always available for you on every day 24/7. You will immediately get the answer. So, is there any question further? Okay. So, if this is the scenario of today, I hope that if you go through more lectures of week 10, week 11, week 12, you may there may be some questions will arise in your mind. So, please do not hesitate to write us through NPTEL portal, that is a much easier, so that I can always have a look, and I will again necessary, if necessary, I will again come back to this live, and thank you very much for listening today. Thank you.